Okay, ladies and gentlemen, so now let me introduce to you about the t-test. So as you know, the t-test is actually to test for the comparison of mean. So we got this one is the objective. The requirement of the t-test is as follows. So your data, the first one must having one numeric data, which is we call it as DV lah. And then we got the nominal ordinal data, which is we call it as the IV. But this one must have the group is only equal to 2. Maknanya dua kumpulan sahaja. Cannot more than 2. And then the data must be normally distributed. Okay, so far so good. So the first one we have here is the PET t-test or dependent sample t-test. So the t-test is actually consists of two idea here. The first one, if you want to test the same group but different time frame, we are going to use the PET sample t-test. And then another one will be the independent sample t-test, where we want to compare between the two groups, which is the independence group. One group is independent to each other, so we are going to independent sample t-test. So the PET sample t-test and independent sample t-test utilizing the same criteria of hypothesis testing, which is the first one, state your null and alternative hypothesis. So you state your null and alternative hypothesis is a must. You must know how to state your null and alternative hypothesis. So in this case, we are going to assume that the mu1 is equal to mu2, which is the mean of the group 1 is equal to the mean of the group 2. Okay, and then the next one is the mu1 is not similar with the mu2, which is the group 1 punya mean is not equal to group 2 punya mean. But this one we call it as the non-directional hypothesis, which is we are not indicating any direction. We do not say that the mean of the group 1 is more than group 2 or vice versa. We are not going to discuss that one in this case, never mind. Just to let you know that if you see like this, that's mean non-directional hypothesis. When we say non-directional hypothesis, that means we are considering at two-tail. Where the two-tail will come out, the SPSS are going to give you lah, whether it's one-tail or two-tail. Okay, so let us begin with the analysis of data using this kind of example. So we have the examples of this thing. So the first one, we are going to analyze the data that consists of the perception or the data set between the pre and post study of those who are enrolling the training program about the participant knowledge on the ICT. So this is the pre, this is the post one. So what is our null and alternative hypothesis? Can anybody here in this class suggest to me what is our null? Our null is what? Pre is equal to post lah kan, betul tak? So our alternative hypothesis will be pre is more than post. We have the direction here. Why we need to have a direction? Because we want to know whether the ICT, this one, the hint is here ni, improve ni. Whether the training program improve. So the words improve here is basically want to guide you that we are perceive or we are assume our data will be something like student do not know and then suddenly they become clever. So that's mean we are going to use the directional hypothesis. We want to see the changes lah before and after. Of course, our perception we say that we hope our changes will be higher marks lah at the end of the course. Betul tak? You buat course tapi lalas orang sama je dot bijak juga, tak guna you buat course kan? So this is how you want to enter the data. So most of you already enter the data, right? So now give me some time so that I can also enter the data and then share with you how we want to analyze this data together. So the first one, you need to set your variables of data. So to setting up your variables, the first one you need to put the pre and post. So some of you are indicating the ID whatsoever, it's all up to you lah. So I just want to speed up the process. Up to you, it's okay. It's good to practicing the normal way of doing things. It's just this one is just to speed up the process because for the interest of time, so I'm going to speed up. I'm going to just skip that one lah, that step. Tapi bila you buat the real research, you must able to do so lah. So 15, 18, and then the next one is 13, 17. Okay, the next one will be 9 and 8, and then the next one, last but not least, is 18 to 8. Okay, this one is actually your data. So how we want to analyze this thing is very simple. You are going to click analyze, you are going to compare the mean, and then you are choosing the PET sample t-test because we want to run the PET sample t-test assuming that this data are normally tabulated. So you can just put the variable one here and their pairing is on this side lah. And then as you know, inside the question here, they already said that the alpha is equal to 0.01. So we need to change this one into 99% of confidence intervals. Okay, we need to change this one first. And then after that, you click OK button. So after you click the OK button, you are going to see and observe this kind of output lah. So based on this, we got the mean of the pre is 12.3, the mean of the post is 15.1, and therefore we receive the idea of the significant here. Now we see the significant level is here. So I want to ask you, this level is 0.001, is less than or more than our alpha. Our alpha is equal to 0.01. More than or less than alpha? Less than alpha, and therefore you are going to reject or fail to reject your null hypothesis. Yeah, very good. You are going to reject your null hypothesis, and therefore you are making a conclusion that there is a significant improvement or significant increase of the pre and the post results of the ICT marks lah after implementing the ICT educational program, whereby we can see here from 12 increase to 15. So this is the example if you want to do the data analysis regarding the PET sample t-test. So far so good? Very good. So you can just follow through for the second example. I'm not going to discuss that one. So this is how you want to tabulate the data. What is that, ma'am? If you see here, the result given here is 0.05. I forgot to tell you that 0.01 is for 2 tail. So you need to divide by 2. Okay, this one. If you see that the analysis will be like this, right? Analyze, compare mean, PET sample t-test. You click OK button. You will get something to do with 0.001. This one is SIG 22222 tail, and therefore this is directional hypothesis, right? And you need to divide it by 2. So after you divide it by 2, and therefore we are going to say that our p-value are no longer 0.001 but 0.005, because this is a one directional hypothesis, and therefore you need to report like that lah. Understand or not understand? Because you still can see the number 1 here. If you cannot see anything, for example, you see like this kan, and therefore you will say that this is less than 0.001. Okay, because you still can see and observe the value from the significant 2 tail given by the SPSS, and therefore you need to report it accordingly. So in this case, we are using the directional hypothesis because we want to see the changes based on the before and after effects. Okay, and therefore if you see, the truth one will be this one. Why this one is the truth one rather than whatever that you got just now? Because this one is assumed to have the data which is already being divided by 2 at the significant 2 tail. Faham kan kenapa dia jadi 0.005 ni? Faham? It's not something that miracle of God coming from the sky. No, it's actually a theoretical basis. So your t value is the same, but this one is forgot the minus value lah. By right, you need to put the minus value. It's just the value, and then you need to report the mean and standard deviation, because this is the center and the dispersions of the data based on the tabulated data normally. Okay, so far so good. Okay, now we are going to see another example for the independent sample t-test. Can we proceed on that? So this is the independent sample t-test. Okay, I skip the examples of the number 2. Okay, that one you can run by your own lah, at your piece of time lah. When you free, you do it lah. When you do it, you become clever. When you not do it, you become average clever. Okay, if you want to become a super clever, you do it yourself. Okay, DIY. Okay, the next one, we call it as an independent sample t-test. So as a prerequisite of the independent sample t-test, they have this kind of formula, or they have this kind of considerations that you need to focus on first, which is we call it as the homogeneity of the equal variance test. So the equal variance test is automatically given to you by the SPSS. So if you see, this one is the first table. Okay, wait, I'm not sure why this thing is happening to my selections and also running the independent sample t-test. Of course, you need to have the null and alternative hypothesis. So we assume that the mu or the mean of the group 1 is similar with the group 2. And therefore, we want to find out whether there is a significant difference or not statistically between the 2 groups. Okay, this is the step. Okay, and then the next one, we are going to the example. So this is the example, right? So you write already the example here inside your data, or you're not writing it yet? Not writing it yet. Never mind. We write it together. The first one will be the group lah. You got here is the group. GROUP group, and then the second one will be the stress. Okay, based on this question, a study was conducted to compare the job stress between two employee groups, administrative and support group. Data was solicited from the randomly selected samples. Test the test or hypothesis on the differences at the level significance of 0.05. State the null and alternative hypothesis. So, okay, I'm going to ask you again and again, what is your null hypothesis, ladies and gentlemen? Your mu1 is equal to mu2. That's mean the admin contain the similar stress with the support group. Okay, that is your null hypothesis. What about your alternative hypothesis? Will be the mu1 is not equal to mu2, which is the group 1, which is the admin group, is not similar with the support group. So the second one will be the alpha and so on and so forth. So the first one, you need to name and values it accordingly. The first one is admin, right? Admin, and then the second group will be the support. So this is how you want to enter the data. You cannot enter the data like the first one because this one contains two variables. The first one is the group variables, and then the second one will be the stress level. So you are going to do like this, copy first, and then you need to paste accordingly because you got 10 personnel. So you are going to put the numbers right here lah, 25, 23, and then 23, 24, and then 20, and then the next one will be 19, then the next one will be 24, 22, 27, and 21. Did you enter your data like this? If you did not enter your data like this, so it's wrongdoing, okay? So you must do like this. Otherwise, if you do like before, you do here and here is wrong. It's very, very wrong. Why? Because this one is independent to this one. This one is independent to this one. Correct or not? Because just now the pet sample to test, we are assuming that this one is Ahmad. This one is Ahmad also. Understand? Because it is this one represent the respondent. Okay. So based on this, we got actually 20 respondent. It's not 10 respondent. We got 20 respondent. And then their groups also are significant, not significantly different. They are grouping in terms of independent to each other. One group is admin group. When you are working in admin, you are always admin, right? You cannot have two locations at the same time. Okay, this one is the data. Are you follow or not follow? Or you already unfollow my Instagram? You follow already, right? Oh, sorry. Which one? Oh, okay. Thank you, ma'am. So the next one is 23. So how you want to run this data is very simple. You go here, analyze. You go here, compare mean, and then you are doing the wrong thing if you not stated your null and alternative hypothesis. Okay, you stated your null and alternative hypothesis, then it will be correct. And then go to the independent sample to test, and then you take the group inside the group variables, and then you take the stress you put under the test variables. This one you find out that you cannot click the OK button. Why? Because you need to specify first the group. So you define the group as number 1, as number 2, because computer did not know what kind of values that you set for the each of the group. As you know, we set the group 1 as the admin, 2 as the support, right? And therefore we need to specify under here. And then you click continue button, and then the option button if you want to adjust the alpha value to become more accurate and so on. Okay, and then after that you click the OK button, and then the result are going to be produced by the computer, something like this. So now we are going to interpret the data. So based on this, the first one you need to look at the mean. The mean are kind of differ, correct? 22.8, and another one will be 22.1. Okay, the first one, the rule of thumb to use the independent sample to test, you must focus on the first box. This is the first box that I'm talking about. This is about the Levine test for the equality of variance. It's measure whether the variance are equally the same or not equally the same. So the first thing that you need to understand is looking into the SIG value. So if your SIG value are more than 0.05, and therefore you need to focus on the first row, okay? If your value here is more than 0.05. So in this case, more than or less than 0.05? More than. Therefore, you need to focus on the first row. Forget about the second row. So you can just blind your eyes, or you can use the marker to what? To remove that things lah. Use the marker and then tutup dia punya gambar tu kat situ. Or if this thing is less than 0.05, then that means we need to use the second row. Okay, that is the condition, the first one that you need to understand. So in this case, we are using we are observing that the Levin test for the equality of variance is more than 0.05, and therefore we assume that the variance are equal, and we are going to only focus on the first row. So inside the first row here, we are looking into the SIG. You see there? You see here is 0.546. So this is the p-value. And then what about the t-statistic? The t-statistics is equal to 0.615. So this one is more than or less than alpha? Correct. It's more than alpha. So reject or fail to reject null hypothesis? Correct. Fail to reject the null hypothesis. And therefore, what is your conclusion? Mu1 at mean stress level are equal with the support group stress level. So that's mean whether you work in the admin or you become a support group, you are having a similar stress level. Okay, that is how we want to do, and that is how we want to justify the data, whether it is similar or not similar. So far, so good. So good, okay. So that is enough, and that is all for your data analysis for the independent sample t-test and also packed sample t-test, okay. So this is how you want to do it, and this is about the interpretation, and this is about how you want to present the data accordingly using the way of the thesis write-up. So this is the conclusion that you should give. Fail to reject the null hypothesis. Conclude that there is no significant difference in the job stress between administrative and support group at a point of level significant 0.05. And this is for the second one. So if you got time, you can do it. I don't have time. I don't want to do it. So please do it. Okay. This is an application. Okay. Provided by yourself, by your good self before this that we are collected. So this is the way that you want to present your data accordingly, but this one is not correct because no line exists here, so you must adjust accordingly. So if I got time also, I'm going to share with you, this is the example if you want to make the comparison between male and female for the independent sample t-test for the job satisfaction and set category based on what you write up and what the data that you collected in your samples. Okay, now please open your data now. Which data that I'm talking about? The data that I already shared with you inside the websites, okay. The data is what name? I can't remember the name of that data, but you can open lah. You can open accordingly the data. Can you see the data or not? Do you know where to obtain the data? You did not know how to obtain the data? Never mind. You can just go to my website kajidataonline / what is your group? ADOC18, ADOC18, which is your specific page that I created for you, so that you can download all of the story that I'm sharing to you. So this is the questionnaire in a word form that I mentioned to you before in making up online questionnaire. This is the data asal MS Excel, tidak edit. This is talking about the MS Excel that being extracted out from my Google Drive, and then this is the Excel file that already being adjusted accordingly in terms of the copying it and then paste it into the SPSS, and then this is the SPSS file that I need you to download it. So after you download this data, these files, and then you can open it accordingly lah. So please open this kind of file so that we can done the similar analysis for the packed sample or independent samples if there exists, so that you can further understand. This one, data for analysis. You open the data for analysis now, and then after you open it accordingly, it will pop up something like this lah. So this is your data, right? Okay, you have the data already? Okay, now we want to analyze. For example, we want to know, is there any difference between the salary of those who are gender and also institute? You got what I mean? kajidataonline.com/ADOC18. That is our website, okay? That is the only website or the link that I'm going to share everything that we discussed today and tomorrow. Okay, the first step that I'm going, okay, never mind. The most important thing is please open your SPSS file, okay? This is your SPSS file, you open it already? Yes. Very good. Okay, jump forward. Okay, this is your data. So now I'm going to test a hypothesis, some of the hypotheses, okay? Before we run the analysis of this question, I'm going to just run the analysis based on the demographic itself. For example, in this overview, we know that you got the salary, correct? So I want to know whether your salary is differ or not differ according to your institutional background of study kan. Contohnya you kerja LKKM ke non LKKM, which one of you possess more salary? Example only, okay, because we want to run the independent sample to test. So how to run that one? You go to the analyze, compare mean, and then you must understand this data is not run for the normality. So first we need to run the normality test first, okay? But we skip lah, we assume that our data is not normal. And then please go accordingly, analyze, compare mean and independent sample to test. And then after you click that one, please insert the ruler scale here, salary inside the test variables. And I'm going to compare between institution, INSTIT, institute. This one, just go here, grouping. But this one, I can't remember what is the, okay, the group will be 1 and 2. So just put here 1 and 2. And then click continue button and then OK button. So after you click the OK button, it will come out like this lah. Okay, it will. Very good. So this is our independent sample test. And remember, analyze, compare mean, independent sample. Not one sample, not mean. Independent samples. If you cannot see the similar pattern of this thing, that's mean you are running the different analysis. Okay. Ladies and gentlemen, so now to begin with, actually you need to run using the hypothesis testing. So the first one is your null and alternative. What is your null? Your null will be the mu1 is equal to mu2, correct? That means those who are working, those who are from the ILKKM having a similar salary from for those who are not from the ILKKM. I mean, you are studying the different colleges, it's okay. Okay, and the next one, our alternative will be the mu1 is not equal to the mu2. This is our null and alternative hypothesis for the first step. So far so good. You follow or not follow? Correct. Okay, the next one is your alpha. So Jumhur Ulama suggested that we set at 0.05, and then the third one we run the analysis and then we report what we need to report. Okay, this is what we are going to discuss today. The first one, look into this particular box. So this box indicate that it is more than or less than? More than our alpha or 0.05, and therefore we need to focus the first row or second row? Very good. So we need to focus on the first row. So we need to report our first row in terms of the p-value. What is our p-value? 0.707. And then what about our t-statistic? Our t-statistic equal to minus 0.380. So I'm going to run it and then followed by the fourth step, which is we make a decision. So based on your p-value, 0.707 is more than or less than our alpha? Good, more than our alpha, and therefore you reject or fail to reject your null hypothesis. Correct, you reject, no, you fail to reject your null hypothesis and you make a conclusion. So I want to hear some a good conclusion that you can give and share with me. What is your conclusion then based on your decision made in the step number 4? There is no significant difference of salary between those who are studied from the ILKKM or non-ILKKM. Okay, that is our conclusion. Okay, there is no significant difference for the salary between those who are working in those who are studying from ILKKM and non-ILKKM at the point level of significance 0.05. Okay, even though using your naked eye you can see that this ILKKM obtained 3,288 and then another group will be 3,362. Approximately little bit higher, walaupun mata kasar you kata this one is much more higher than this, but actually statistically is not differ. Okay, so it's a good findings. So that's mean why we do this analysis in the first place, because we want to know is there any influential factor. So that's mean it's nothing to do with your salary that may influence your awareness. It doesn't say that, okay, if I got more salary, I got more knowledge. No, because it's already proven here. Because even though you got a very high salary, or even though you got higher little bit salary because of you are studying outside or studying elsewhere, you are actually having the same salary. So this is the example if we want to identify a risk factor. Okay, this is the good example of that. But that is not the real story actually, because we want to compare the awareness level. But that one I'm not talking to you, I'm not discussing with you Now, I'm going to explain to you after this. Okay, so far so good with the independent sample t-test and paired sample t-test. Okay, now example I want to give you if you want to test the data with the standard. So if we want to compare with the standard, so we are going to use the one sample t-test. Did you remember that explanation yesterday that I'm giving to you? We are going to use the one sample t-test if we want to compare with the standard. With the standard, for example, we have a standard of kemiskinan is 3,000 lah, 3,500. So we want to compare whether you all are miskin or not miskin. For example, in terms of your salary. So how to do that is very simple. The first one, you go to the analyze, compare the mean, and then go to the one sample t-test. After you go to the one sample t-test, then please pick up whatever that you want to compare with your standards. For example, in this case, I'm going to compare with the salary with the national indicator salary for nurses, for example. 3,500 is my capping point. So if you are more than or less than 3,500 as my justifiable mean. So after I run the analysis, so this is what will come out from the result. I'm obtaining 3,311. So this is my test value 3,500, and then I'm looking into the significant total is around 0.042. So it significantly differ, correct or not? Because you reject the null hypothesis. You understand or not understand what I'm saying to you? This one, this one. What is your null? Your null will be mu is equal to standard lah kan? Okay, your alternative is mu is not equal to the standard. Okay, this one is non-directional hypothesis. If directional hypothesis, then this value you need to divide by pandai. Okay, in this case, I'm not going to do the non-directional hypothesis. I'm going to focus on the, I'm going to focus only for the non-directional hypothesis. So in this case, I'm obtaining the level of 0.042 is more than or less than our alpha? Less than our alpha. So if less than our alpha, we reject or fail to reject one null hypothesis. Very good. So we are concluding that there is significant difference between the mean of the population with the standard. So where is the standard is 3,500. So you all are obtaining around 3,300. So they have some significant difference lah, 200 less lah kan. So therefore you continue your study, right? To boost it up, okay? To boost it up a little bit more so that you can approaching to the national standard. So this is just a joke, okay? Because there is no standard for your salary. If you perform well, so you get paid well lah. Okay, so far so good, ladies and gentlemen, about the explanation for the t-test. Okay, just a quick glance, just a quick overview. If your data is not normal, then you need to do the second approach by producing the result from the non-parametric analysis. So the non-parametric analysis can be obtained down here. Okay, I make a repetition. If your data is not normal, then you are going to use the analyze non-parametric test and proceed with the two independent samples, which is we call it as a Mann-Whitney UZ test. Okay, you just click here, and then it's similarly the same like before. You put the salary here, you put your grouping box inside here. Sorry, institution, right? So you define the group as the number 1 and 2, and then after that you click continue, and as default the computer are going to select as the Mann-Whitney UZ test, and then you are going to click OK button, and this is what we are talking about, the assumptions of significant. Okay, the assumptions of significant for the non-parametric analysis are being discussed below lah. This one. This one is Mann-Whitney. This one is the Z statistic. So the Z statistic is equal to minus 0.860, and then your p-value for the assumptions of significant total is around 0.390. So that's mean there is no significant difference in terms of the two groups that you are conducting the test. Okay. So far so good, ladies and gentlemen, members of the floor. So far so good, right? Okay, never mind. If I'm explaining too fast,